Hello and welcome back to another Orange Coast College Mathematics video. In this video we're going to talk about operations on complex numbers. So as a refresher, what is a complex number? A complex number takes the form of a plus bi, where a and b are both real numbers, so like 3 plus 5i for example. And if it's written as a plus bi, it's considered to be in standard form. Now if you have two complex numbers, a plus bi and a minus bi, those are called complex conjugates. Now, when adding or subtracting complex numbers, you want to make sure that you keep the real parts together and the imaginary parts together. So let's go ahead and try it. For number 1, we have 2 plus 5i plus 7 plus 3i. So we can go ahead and rewrite this with the real parts together and the imaginary parts together. So we have 2 plus 7 plus 5i plus 3i. And so we can even group them in parentheses if you like. Then this becomes 9 plus 8i. Since we have a plus bi, this is in standard form. So let's move on to our next one. We have 1 minus I minus negative 2 plus I. So this minus right here is going to distribute normally, just like how you would expect it to. And so this becomes 1 minus I minus negative 2 minus I. So now let's regroup everything. We have for the real parts 1 plus 2, and then for the imaginary we have negative I minus I. So this then becomes 3 minus 2i, and that's in standard form, so that's our final answer. Moving on down to number 3, we're going to be multiplying. And this is going to work exactly the same like how you would multiply any two binomials together. We're going to FOIL things out exactly like normal. So we're going to multiply the 7 to the 1, the 7 to the 6i, and then we'll have a negative 2i times 1, and then a negative 2i times 6i. And then we'll add everything up. This becomes 7 times 1 is 7. And then 7 times 6i is going to be 42i. Then we have negative 2i times 1, so that's going to be minus 2i. And now we have negative 2i times 6i, which will be negative 12i squared. Now before we move on, what is I squared? Well, I is the square root of negative 1, and so the square root squared cancels each other out. And so really, I squared is just negative 1. So this is negative 12 times negative 1, positive 12. Now we can group our numbers together. So we have 7 plus 12 plus 42i minus 2i, which becomes 19 plus 40i. Since we have a plus bi, it's in standard form. Moving down to number 4, we actually have complex conjugates, right? If we look at our numbers, we have 3 minus 5i and 3 plus 5i. It's the same a and b, except this is a minus sign and this is a plus sign, right? That's the only difference between conjugates, is that the sign is different. So what happens when we multiply complex conjugates together? Well, let's go ahead and FOIL everything out. We get 3 times 3 is 9, and then 3 times 5i is going to be plus 15i. Now negative 5i times 3 is going to be minus 15i. And now we have negative 5i times positive 5i. So minus 25i squared. So what do we have? First off, we have an I squared. So an I squared is going to be negative 1. So really, this is negative 25 times negative 1. However, we also see that I have positive 15i and negative 15i. So when I add these together, they're just going to cancel each other out, and we're going to get 0. So what am I left with? I'm left with 9 plus 25 with no imaginary part. I just get a real number, 34. So Just like how when we multiply normal conjugates together, we get rid of our square roots, when we multiply complex conjugates together, we get rid of our imaginary part. Moving on to number 5, we have 3 plus 2i quantity squared. So let's just go ahead and write it out. So 3 plus 2i times 3 plus 2i, we get 9 plus 6i plus 6i, and then 4i squared. Now the I squared is going to be -1, but now we can group everything together and add everything up. So we have 9 minus 4, so 9 minus 4 is 5, and we have 6i plus 6i, which is 12i, so plus 12i. So we have a plus bi, so it's in standard form. Now let's try division. But we still want to write our answer in standard form, as in I want a plus b times I. So I'm not going to want an I in the denominator. So let's first start off by separating our fraction into two pieces so we have something plus something, in hopes that we can get it to look more like standard form. So this becomes 6 over 5i plus I divided by 5i. Well, I see that I have an I in the numerator and in the denominator, so those are going to cancel out. And we are left with 1 over 5 plus 6 divided by 5i. Now, this is super close to standard form, but we're not quite there because we don't have an I in the numerator, we only have it in the denominator. So how do I get rid of that? Well, I can multiply by 1 in a creative way. As in, I can multiply by I divided by I. Notice that I'm multiplying by 1. So I'm not actually changing the value of anything, I'm just making it look differently in a convenient way for us. So, what does this become? This becomes 1 over 5 plus 6i divided by 5i squared. But what is I squared? -1. So this becomes 1/5 minus 6 over 5 times I. Since this is of the form a plus bi, it's in standard form, and that's our final answer. Moving on to number 7, we have 2 divided by 1 minus 4i. So just like when dealing with normal radicals, I can't just multiply by I divided by I in order to get rid of the I on my denominator. I have to multiply by the complex conjugate. So, what's the complex conjugate? It's going to be the same numbers, 1 and 4, except the only difference is that I'm going to multiply with a plus sign instead of a minus sign. So, multiplying by the complex conjugate divided by itself, we're going to have 1 plus 4i divided by 1 plus 4i. Again, I'm multiplying by 1, so I'm not changing the value of anything. I'm just making it look different. So, let's go ahead and multiply it out. We get 2 plus 8i divided by 1 plus 4i minus 4i minus 16i squared. So, what do we see? So this is a -16 times I squared. That's going to be a -1. And we have a positive 4i and a minus 4i. So those two are going to cancel each other out. So we're left with 2 plus 8i divided by 1 plus 16, which is 17. Now we're super close to being done. This isn't technically in the form of a plus bi. To write this in standard form, we have to separate this into two different fractions. This becomes 2 over 17 plus 8 over 17i. And that is our final answer. Moving on to our last problem, we have a complex number divided by another complex number. Now we might be thinking, okay, well I need to multiply by a conjugate just like I did in the previous problem, but which one am I supposed to do? Am I supposed to do the conjugate of the numerator or the conjugate of the denominator? Well, we want to get rid of the imaginary numbers in the denominator. That's where we have our problem. So, we want to do the conjugate of the denominator. So, The only difference is that it's going to be a plus instead of a minus. So we multiply by the conjugate of the denominator divided by itself. So 4 plus 2i divided by 4 plus 2i. This then becomes negative 3 times 4 is negative 12. Negative 3 times 2i is going to be minus 6i. 7i times 4 is 28i. And then 7i times 2i is going to be plus 14i squared. Now we go to our denominator. We have 4 times 4 is 16, and we have 4 times 2i is 8i. Negative 2i times 4 is minus 8i, and then minus 2i times positive 2i is minus 4i squared. We know these I squareds are going to be negative 1s, so we can start grouping everything together. We have negative 12 plus 14 times negative 1. 14 times negative 1 is going to be negative 14. So negative 12 minus 14 is negative 26. Then we have negative 6i plus 28i. So that's going to be positive 22i divided by 16 minus 4 times negative 1. Well, minus 4 times negative 1 is going to be positive 4. So 16 plus 4 is going to be 20. But we also see that this positive 8i and minus 8i are going to cancel each other out. So we have no imaginary part in the denominator. Now we're almost done. We need to put it in standard form. So it needs to look like a plus bi. So let's separate this into two fractions. This becomes negative 26 divided by 20 plus 22 divided by 20 times I. Even though this is in standard form, we can actually simplify these fractions a little bit more, so let's go ahead and do that. This becomes negative 13 over 10 plus 11 over 10 times I. And that is our final answer. That's going to do it for this video, and I hope to see you in the next one.